Welcome to lecture series on data structures. In today's lecture series, we will discuss about a non-linear data structure called as tree ADT. So far we have discussed the linear data structures such as a list, linked list, stack and queue, uh, where the elements are stored in a sequential order. But in today's lecture series, we will discuss about tree ADT, which is a non-linear data structure. So before going into what tree ADT is about, let us have a general understanding of a normal tree. How does a normal tree will look like? So now we have drawn a tree over here and all the parts of the trees are marked in the way that it grows. So when we look from the bottom to the top, we have root at the bottom and followed by trunk. Then we have the branches. At the end of each branch, we have leaves and fruits. So this is a general representation of a normal tree. Now, imagine this tree in an upside down format as shown here. Now imagine that the tree is growing from top to bottom. This is how it will look like, right? So now root comes to the top, followed by the trunk and the branches. So at the end of each branch, what do we have? We have leaves. So look at the end of each branch. Each branch has leaves at its end. So this is how a general tree data structure will look like. So this is the general representation of a tree data structure. Now we will discuss this tree data structure with an example. Now, if you consider electronics of our use, its subdivision will have R&D, sales, purchase department, and manufacturing department. If you take the sales department alone, it has again two branches such as domestic sales and international sales. If you take manufacturing department, it manufactures CD, tuner, and TV. If you take international sales, sales will be done to Canada, South America, and overseas. In case of overseas sales, it includes Africa, Europe, Asia, and Australia. So this is a general representation of a tree data structure. So a tree ADT can be considered as infinite collection of nodes where each node stores the data or the information. This tree represents the parent-child relationship, and this is a uh, this is considered a hierarchical hierarchical structure which is done recursively, and of course it is a 2D data structure. They all the data is stored in 2D format. Now let us look at the various terminologies we use in tree data structure. So these are the various terminologies we use in tree data structure. Root is the first node in a tree. Any link between two nodes is called as the edge. The value stored inside the node is called as the key. Two nodes having same parent is called as sibling nodes. A parent is a node that has branches or that has child nodes. A child node is the one that has a parent. So the height of the tree is the number of edges from the particular node to its leaf. Depth of the node is the number of edges from root to the particular node. So any part of the tree is considered as subtree. So these are nodes that have no children are considered as leaf nodes. So these are the various terminologies that we use in tree ADT. So these are some of the advantages of tree data structure. It reflects the data structural connection, and it supports hierarchical representation, and insertion and deletion can be done efficiently with the help of tree data structure. Some of the applications of tree includes file system, dictionary, and network routing. In case of file system, for example, if I'm storing a folder inside a folder in the desktop, it is listed as in C directory. Inside the desktop, we have a folder called as X, and inside that folder we have a file called as a.txt. So this is the file system representation which is done with the help of tree data structure. So these are the various applications of tree data structure. Hope you have understood what is tree ADT, what are the various advantages of using tree ADT, the terminologies that we use, and its application. So in the next data structure, we will discuss about the next lecture series, sorry, we will discuss about the various tree traversal techniques. Thanks for watching. So this is an assignment for you to cover. So here you need to circle all the leaf node and you have to put square box around the root. You have to put a star or draw a star around each ancestor of the node that contains 10 and X through the descendant of the node that contains 10. So these are some of the references. Thanks for watching.